mathematical induction. To prove that 1 raised to the power 2 plus 2 raised to the power 2 plus 3 raised to the power 2 plus plus n raised to the power 2 is equal to 1 over 6n into n plus 1 into what? 2n plus what? 1. Okay. Now let's go. Solution. That says if n is what? A positive integer. A positive integer is the same thing as what? A natural number. You will see them in what? In the right hand side of what? Number line. So they are what? Those words counting numbers. They are just a gift from God. Okay. Example of them are 1, 2, 3, 4. Solution. Now let's solve. Okay. We are going to look at step 1. Step 1, known as what? Base step. And that base step we now test. Let us test for p of 1. That is n when n equal to 1. From this equation you can pick. Let's divide this thing like this. Here is the left hand side. Now we pick 1 square. Is it equal to n square? 1 square, is it equal when n is 1, which is 1 square? So 1 is equal to 1. Hence, p of what? 1 is true for all positive integer n. Now let's go to the right hand side. Now 1 square, is it equal to 1 over 6 n into n plus 1 into what? 2n plus 1. Now let's go. When n equals to 1, we have 1 square is equal to 1 over 6 into 1 plus 1 closes plus. Now let's go. Plus what? 2 into 1 plus 1. Close it. 1 square, is it equal to 1 over 6, 1 into 2 into what? 3. Close it. 1 square, is it equal to 1 over what? 1 over 6 multiplied by what? 6 over 1. This will cancel now. We have that 1 square is equal to what? 1. And 1 square is equal to 1. So hence, p of 1, p of what? 1 is true for all positive integer n. So case 1 is true. Okay, now let's go to case 2. Step 2, which is what? Inductive step. Inductive what? Step. What do we do here? Let us test for p of k. That is when n equals to what? K. From the equation we have 1 square plus 2 square plus 3 square plus 1 plus n square. Is it equal to what? 1 over 6 what? n into n plus 1, close it, into 2n plus 1. And remember they say when n equals to k, that means when n equals to k, from this equation we now have 1 square plus 2 square plus 3 square plus what? K square. Is it equal to 1 over 6 k into k plus 1, close it, into what? 2k plus 1, close it. So we can call this in equation 1. Call it what? Equation what? Equation 1. Equation 1. Okay. Now let's go. Step 3. Case 3. We call it step 3. We have it as inductive what? Inductive hypothesis. Now, what do we have? Let us test for P of K plus 1. That is, when N equals to K plus 1. From this equation, that is the original equation given to us, we have that N1, 1 square plus 2 square plus 3 square plus N. Anyway, you see N, call it what? K plus K plus, now we are going to add what when K plus 1, which is K plus 1 raised to power what? Square. N raised to power is, okay, which this is equal to what? 1 over 6 into what? K plus 1. Anywhere you see N, call it K plus 1. Okay, into what? K plus 1 plus 1, close it, into what? 2 bracket K plus 1, close it, plus 1, close it. Okay, finally we have 1 square plus 2 square plus 3 square plus K square plus K plus 1 square. Is it equal to 1 over 6 K plus 1, close it, into what? K plus 1 plus 1, which is 2, close it, into what? 2K. We have this one as 2K, 2K, 2 times 1, which is what? 2, plus this, we have it as what? 3, plus 3, close it. So what are we going to prove? So that we know that P of what? K plus 1 exists. We will prove that this left hand side is it equal to this right hand side. That is our argument. If we solve this and expand the left hand side, and after the expansion, the answer we give, and we expand the right hand side, after everything we have the same answer. We now know that the P of what? 1, the P of K plus 1 exists. But see, after expanding left hand side and right hand side, and the answer that is in left hand side is not equal to the answer that is in right hand side, you now know that the P of K plus 1 does not exist. That means the principle of mathematical induction cannot work on it. Okay, now let's go. We are going to expand the left hand side one after the other. After expanding the left hand side, we expand the right hand side and see our answer. Okay, for left hand side, so this left hand side from here to here is the same thing as this. So we are going to say recall that 1 square plus 2 square plus 3 square plus N square, or K square, sorry, plus K square plus K square is equal to what? 1 over 6K into what? K plus what? 1 into what? 2K plus what? 1. So that is 10. So now, if this is this, that is from here to here, so plus, that means we are going to have this in as 1 over 6 into what? 1 over 6K into K plus 1 multiplied by 2K plus 1, close it. So we have a very big bracket, plus, what do we have? K square. K square means what? K plus 1 into what? K plus 1. Now that is what we are expanding. Now what do we do here? 1 over 6 k in bracket. K times this we have 2k square. Times this we have what k. 1 times this one have as what 2k. 1 times 1 we have as what 1 plus 1 close it plus k times k square. K times 1 plus k times 1 plus what k. 1 times 1 is what 1 close it. Okay, now we have 1 over 6 into what into k. This to this we have 2k square plus k to this 3k plus what 1 close it plus k square plus 2k plus 1 close it. Now we have another k here which is 1 over 6 into what into 2k power 3 plus what 3k power 2 plus what k close it plus k square plus 2k plus what 1. Okay, analysis. Now what do we do? Let's continue. This place we have this as 2k power 3 plus 3k power 2 plus k all over what 6 plus k power 2 plus 2k plus what 1 all over what 1. What is the LCM? 6 and 1. LCM is what 6. 6 go to this 1 multiply everything. We have 2k square power 3 2k power 3 plus 3k square plus k. Now go to this go to this plus 6 go to this. We have it 6k square plus 12k plus 6. Now collection of like term 2k power 3 2k power 3 plus square will give us 9, which is 9k power 2. K plus this will give us 13k plus what 6 all over what 6. Call it equation T. Equation T. Now we have succeeded in getting what to the left hand side to be what equation T. So now let's go to right hand side and know whether we are going to expand and get the same thing. For right hand side we have that 1 over 6k plus 1 close it into bracket k plus 1 plus 2 to k to what 2k plus 3 close it. So very big bracket. So now what do we do here? We expand. Now let's go. 1 over 6k plus 1 close it into very big bracket. K times 2k will give us 2k square. K times 3 will give us 3k. 2 times 2k will give us 4k. 2 times 3 will give us plus what 6 close the bracket. We now have 1 over 6k plus 1 into bracket 2k square plus 7k plus 6 close the bracket. Now let's multiply. We have 1 over 6 into now k times 2k we have it as 2k power 3. K times 7k we have it as what 7k power what 7k power 2 power 2 plus k times 6, we have it as 6k. Now let's go. 2 times this, we have it as 1 times 2k, have it as 2k square. 1 times 7k, we have it as 7k. 1 times 6, we have it as 6. So, and that is 10. Okay, from that side. Now, let's have this in ours. Let's continue. We have this expansion, collection of what like them. For the right hand side, we see for the right hand side, collection of what like terms. We have 1 over 6 into what 2k power 3 plus this one and this one will give us 9k square. 6k and 7k will give us plus 13k plus what 6. Close it. So this is the same thing as saying that 2k power 3 plus 9k square plus 13k plus 6 all over what? All over 6. Call it equation P. Equation T. You cannot say hence equation T is equal to equation P. Therefore, P of k plus 1 is 2. That is how to solve. If you look at this equation, we have 2k square power 3, 2k power 3, 9k square, 9k square, 13k, 6, all over 6, they are equal. So having done that, if the right hand side, left hand side is equal to the right hand side, you can now conclude that the P of k plus 1 is what? True. Generally, you can say hence, generally, P of 1, P of k and P of what? K plus 1 are true for all positive integer what n. That is how to do it. Thanks and God bless you. Remember to subscribe to my YouTube channel, Prismatics Online Class. Follow me on Facebook, the same Prismatics Online Class. Please like, share, and comment. Thanks and bye-bye.